Hello, science superheroes. It's time to do some physics. Um, you might want to pause this and write down the question so you have these examples in your notebook. Okay, so just to remind you of the formulas that we are going to use, I'm going to write them all down right here for you, so make sure you're using these formulas. Velocity, and that's final velocity, right, because there's no subscript, is equal to initial velocity plus acceleration times time. And then we have a new one. Well, if you watched the video before, you noticed that average velocity can be final velocity plus initial velocity divided by 2. That's if acceleration is constant. Remember that? And then if you put these two formulas together, you can get this formula. X is for displacement, v sub naught t plus 1/2 at squared. And yeah, I've asked you to write these down a lot, but that's because the more you write them down, the more familiar you will be with them. And our third kinematics equation is v squared equals v sub naught squared plus 2ax. So you have to remember everything that we talked about in that last video about sign conventions and things like that, because if you mess up your sign conventions today, you'll get all of your math wrong. So what I would suggest is write these formulas down at the top of your homework every time until you have them memorized. Okay, another thing that, if you're going to ask me for help, I'm going to say, the first thing I'm going to ask is, do you have your formulas written down? The second thing is, do you have your checklist? So here's the checklist, and it's almost always the same. Okay, so v sub naught, v, a, t, and x. So initial velocity, velocity, acceleration, time, and displacement. Okay, so this will be a common checklist for you all the time. Okay, so the first thing you do is, read it. A horse trots past a fence post located 3 meters to the left of the gate post. So one thing I kind of like to do is single out the numbers. It then passes another fence post located 4 meters to the right of the gate post 10 seconds later. What is the average velocity of the horse? Okay, so once you do that, you're going to take your numbers and put them into your little checklist here. So it says a fence post located. Well, you know what? I'm going to have to draw a picture because a picture is worth 1,000 words. So here's the track where the horse is. Let me try to figure this out. It says 3 meters to the left of a gate post. So we'll say that this is the gate post. This right here is the gate post. So this is 3 meters. And passes located 4 meters to the right. Okay. So it's 4 meters. And so I'm just going to mark this down so I know that there's a difference right here of 7 meters. And so you want to make sense of as much as you can with the pictures so you don't mess yourself up. And it says it takes 10 seconds. So, okay, well, here's 10 seconds here then. Average velocity. Now, do you see average velocity anywhere in here? No. This is really, after this first couple sections, average velocity won't be something that you are asked to calculate much. But that first formula that I showed you on the other page was average velocity is, I said v plus v sub naught divided by 2. So we look, do we have v or v sub naught or 2? No, we don't. But one of the first formulas that I showed you was average velocity, and I'm pretty sure y'all watched this video, is equal to displacement over time, right? And that was we were talking about going from Bismarck to Fargo and the difference between distance and displacement, velocity, and speed. So that's where this one was. Now it's not considered, you know, a kinematic equation, I guess. You won't find it on any equation sheet. This is one you have to like know, or memorize. Okay, so I think this is the one that we're going to use because we're looking for x. It doesn't give us initial or final, it doesn't give us acceleration. So really, this is all we have to work with here. So this is the simplest of all formulas, but if you're looking to use one of those first big kinematic formulas I gave you, then it's going to be confusing because it's not that hard. So average velocity is displacement per time, right? So the question is, what is this displacement? Positive, negative, what do you think? Yeah, thank you, Isabel. Positive is the way to go. You know, the important thing is you're looking at 3 meters and 4 meters. You're not seeing any directions there. But when you see the word right and left, that gives you an understanding of what they're talking about. So I'd definitely just go with 7. And the time is 10 seconds. So your average velocity is 0.7 meters per second. Okay, now I guess I just kind of jump out here because this piece is supposed to be your opening statement. So make sure that you have your formula that you're using without your variables for your first line all the time. And then your second line will be your substitutions, and your third line is finding the answers with the correct label. Okay, so here's the next one. It says a biker travels at an average speed of 15 meters. So now they're giving us an average along a 9.9 times 10 to the third meter straight segment of a bike path. How much time does the biker take to travel the segment? So this is, again, another one of those more simple problems. Okay, so all we have is average velocity and distance. We're looking for time. So we're going to use that same formula again. But we got to get time out of the denominator there. And then get time by itself. So the time for this situation is going to be displacement divided by the average velocity. In this case, the displacement is do you know how to extend numbers? Or would you like me to refresh your memory on that from the exponents? Okay. So if you look at 9.9 times 10 to the third, what that means is you're multiplying times 10 3 times. So the easiest way to do it is, well, if it's a positive, you just move the decimal 3 times. So that's, now if this would be like, if it would be 9.9 times 10 to the negative third, then you would move it the other way, 1, 2, 3, okay? And so you're either moving the decimal to the right or to the left. That's all you ever do to expand these numbers here. Okay, so 9,900 meters divided by 15 meters per second. How much time is that going to take? So you got 660 seconds. Okay. Any questions on that? Okay, here's our next one. It says a hiker travels south along a straight path for 1 hour. Okay, so I'm going to make sure I see that with an average speed of 5 kilometers an hour, and then travels north for 2 hours with an average speed of 4 kilometers per hour. What's the hiker's displacement for the total trip? And how about his average velocity? Okay, so this is a little bit tougher here, especially the average velocity. And I'm going to show you how to do the average velocity, but it's something that you're not really going to learn about and be responsible for until the next section. Okay, so this one definitely needs a picture. So it says straight south, okay, for 1 hour with an average speed of 5 kilometers per hour. Okay, so 5 kilometers per hour for 1 hour. Okay, so that's 5 kilometers, right? I probably don't have to do that math on a piece of paper. Any questions on that? But if I was trying to figure that out, you know, you just take your velocity equals displacement per time. This is how far you're going, so you multiply both sides by t. T times v equals your displacement. Your time is 1 hour times 5 kilometers per hour. See how that factors out the label. X then equals 5 kilometers. And, you know, it's probably good that I did show you that because these numbers are pretty simple, and that doesn't mean that all of your numbers are going to be that simple. So you're using this formula like an average velocity. Okay. Then travels north for 2 hours with an average speed of 4 kilometers. Okay, well, this is weird. So maybe, I don't know what he's doing. He travels north for 2 hours with an average speed of 4 kilometers per hour. So that's going to be 8 kilometers. Do you agree? And you'd figure it out the same way as this. And I'm showing you these examples, like these are pretty much right off your worksheet, your assignment, with different numbers though. Okay, so what is the hiker's displacement for the total trip, and how about his average velocity? So Andrew has the right answer in magnitude. But let me ask you this. Do you guys remember, if you watch the videos, is displacement a vector or a scalar? It's a vector. And vectors have what? Size and what else? Direction. So yes, Andrew, you're right, it's 3, but there's just a little bit more that you have to add to it. 3 what? Kilometers. Well, it's north. So there's your direction, and you have to have that for displacement. Okay, so the question was average velocity, and at first I thought I was going to do some SOHCAHTOA stuff, but now I realize it's all linear. So even though the guy, you know, was going quite a bit faster, he's going 5 kilometers per hour and then 4 kilometers per hour. His actual velocity, though, is, since it's displacement, his actual velocity is displacement per time, and his velocity displacement was only 3 kilometers. And that took him, how long did it take him? Was it 3 hours? 3 hours. So if you look at the whole time that he was traveling, you got 1 hour here, 1 hour there. So his average velocity is only 1 kilometer per hour. Okay, so his average speed would be much higher than this, but his average velocity, since it's a displacement per time, is only 1 kilometer per hour. Any questions on that?